There are not many of us who at some stage have not fantasized about time travel, perhaps going back to our childhood. But wouldn't it be great to really go back in time, to go back in history and to experience a bygone era, to meet a famous person, or to walk the streets in the 19th century? But we all know it's preposterous, it's impossible, it's a figment of the imagination. Or is it really?
Time is a kind of space, and we can move forward and backward in time just as we can move forward and backward in space.
Ron Mallett is a theoretical physicist at the University of Connecticut and is convinced that time travel is possible. And he's not a crackpot. He's a highly respected academic. He says physics has revealed that it is possible to change time, to reverse it, speed it up, and even to twist it. Ron became interested in time travel when he was 11 years old.
I was a happy kid and the oldest of 4 children. My father was a television repairman. He actually had fought in the Second World War, and he used the GI Bill to study electronic technology. And he was really good at what he did. But he also was a person that loved to have a family.
But then tragedy struck. Ron's father, who smoked heavily, had a sudden and massive heart attack. He was dead at the age of 33.
I couldn't adjust to that. I mean, I really just couldn't adjust to that. And I really went from being a very happy kid to being a very sad. And I suppose that one would have called a depressed, child after that.
However, the one thing that gave Ron joy was reading. It was the comic book era, and there was a series which he particularly enjoyed, which translated classic literature into comic book form.
It was one particular issue of Classics Illustrated, 133rd issue. And I still remember when I went into the drugstore and I saw this issue there, and it said, The Time Machine by H.G. Wells. And I knew this is the answer, because I thought, a time machine, that's it. If I could build a time machine, then I could go back to the past before my father died, and I could see him again and tell him what was going to happen and maybe prevent this nightmare from happening. So it became my passion.
A year later, he came across a popular book on Albert Einstein.
Einstein said that time was not something that was fixed, that time could be altered. When I read that, I said, wait, this means that this genius Einstein said that time can actually be altered, then that must mean it might be possible to build a time machine if I could understand Einstein.
Ron then realized that physics would be crucial for his ambition to build a time machine. After joining the Navy for a few years, he then studied physics at Penn State University, where he eventually received a doctorate. He then got a job here at the University of Connecticut, where he specialized in relativity and black holes. But secretly, he continued to work on his idea for time travel.
I didn't tell my thesis advisor that I wanted to build a time machine. I didn't tell anyone. I thought it would be professional suicide. But also, there were very few African-American theoretical physicists in the United States, and I wanted to make sure that there wasn't going to be one less.
When we visited Ron at his lab, he and some colleagues had built us a model of what could one day be the world's first time machine. A crucial element of his time machine is a continuous circulating light beam. Here he uses the vapor of dry ice to make circulating laser beams visible. To get a light beam to circulate is relatively simple. One only needs a beam and 4 mirrors reflecting the light in a continuous loop. But to really understand Ron's time machine, one has to understand time itself.
One of the key things is that in Einstein's theory of gravity is the fact that gravity can affect time. As gravity gets stronger, the time on a clock will go slower.
This was found to be true when the satellite, which makes the Global Positioning System, or GPS, possible, were launched into space.
The unit in your car has a clock in it. But those satellites, about 12,000 miles above the Earth, have clocks as well. So the engineers found out that the clocks on those satellites were actually running faster than the clocks here at the surface of the Earth. And that was a problem. But whenever they took into account Einstein's theory of gravity, they realized, aha, that's where the problem is. The clocks here at the surface of the Earth are running slower because gravity is stronger than it is at the satellites. So we do know that gravity can affect time.
This is possible because, according to Einstein, gravity has an effect even on empty space. A big body actually bends empty space like this. And Einstein has also shown that time and space are inexorably linked. They're a part of the same continuum. So if you bend space, you also bend time. So gravity can cause both space and time to bend, but gravity is not only caused by matter.
It turns out that in Einstein's theory, not only can matter create gravity, like the Earth and the Sun, but light can create gravity too. So if gravity can affect time and light can create gravity, then light can affect time.
This realization was a scientific breakthrough, and Ron was able to prove this mathematically. And so his design for a time machine relies on the gravitational effect of a circulating beam of light. His theory predicts that the circulating light beam not only bends space, but actually makes it twist and swirl, like tea in a teacup. This twisting of space makes time swirl and twist in the same way. And it's this twisting of time that makes time travel possible.
Normally we think of time as running along a straight line, from the past to the present to the future. And even though we're all unconscious of that, we all do move along that line in time. The thing is that twisting of the space will eventually lead, if it becomes strong enough, to a twisting of time, so that that timeline, going from the past to the present and the future, will be twisted into a loop. And then that will be the thing that allows you to go from the past to the present to the future and back into the past. So that's how one can create these loops, by using a circulating beam of light. So when physicists talk about closed time loops, that's what they're referring to. And they're referring to something that you do to space in order for that to happen to time.
Ron's theories have attracted a lot of attention, and he's also published a book telling his story and explaining his discoveries. His book will soon be made into a major Hollywood film by director Spike Lee. Ron has also patented his time machine.
My work is based on Einstein's general theory of relativity, the equations I developed, the theory that I developed. The question is that technologically, how feasible is that? In fact, there's always that gap between the theoretical and the technological. That even happened with atomic energy equals mc squared. The equation came out long before the practical uses in terms of atomic energy and the unfortunate use in terms of the atomic bomb.
He's now working on getting funding to make his time machine a reality, but he sadly concedes that human beings will probably not journey back in time in his own lifetime. It seems that initially it would probably only be possible to send back subatomic particles in time, but even just that would have major implications, because it would make communication with the past possible.
It will happen. The thing is that one of the positive benefits of it, to me, is that it's an early warning system. You know, imagine if we had a device that could warn us about these massive floods that happen in the world, the tsunamis, the earthquakes, things that take thousands of lives, if we could have a warning of these things.
But if one plays along and imagines time travel, it results in all kinds of strange conundrums, like the well-known grandfather paradox. What would happen if you go back in time and prevent your grandparents from meeting so that your father is never born and you are never born?
It turns out that physics actually has an answer for that as well. The area that I've been talking about has been relativity. The other pillar of modern physics is quantum mechanics, quantum physics. In quantum physics, it's not possible to make precise predictions of what's going to happen next. The only thing that you can do is talk about the probability of things happening next.
One application of quantum probabilities is the parallel worlds theory of the universe.
The moment you arrive in the past, there's a split of the universe, and you arrive in a parallel universe. And in that universe, you can do something like preventing your grandparents from meeting each other. You will just find yourself in a weird universe in which you were never born in that universe, but yet you're in that universe. So the upshot of it is that you can go back into the past, but the past you arrive in is not the past that you came from. So this notion of parallel universes leads to that notion. And this has been something that the idea has been played with in science fiction, but it has its roots in solid physics of quantum mechanics.
So while it might not be possible for Ron to go back in time and meet his father in his lifetime, for future generations, this may become a reality.
But if he could go back in time to meet with his dad again, there are two things Ron would like to say to his father.
The first thing I'd like to tell my father is, I love you. The second thing is, stop smoking.